Now, if I look at graph C, which we've already made the conclusion for that. So there, and we know it's linear because it's a straight line. And we know this is not linear because it's a. How about y equals 2x plus 5?
Yes,
Linear. Degree 1, right? Y equals x squared plus 5? So that's an easy part, right? Where you look at it and then you kind of should be able to determine. Okay. And I don't think you guys have any problems with it. So in real world graphs of linear relations, okay, where I'm talking like, I'm not just giving you a graph and then telling you, you know, here it is. The vertical intercept represents the value of the dependent variable, the what? The y-intercept, okay, the vertical intercept or the y-intercept represents what value of the dependent variable? What do we call that value? No? Starts with an I. Huh? No? No? Initial. That's your initial value. That's what you're starting with. Okay? Right? So I could be asking you for the initial value, and I'll be asking you exactly to find the y-intercept. That's the same thing. Right? So the y-intercept and the initial value are the same thing. The slope represents the independent variable with respect to the independent variable. The thing. Slope, rate of change, they're the same thing. The only difference is the units. All right, let's look at this example. So a cup of coffee is reheated in the microwave. The temperature, C degrees Celsius of the coffee after T seconds can be modeled by the following linear equation. So I have two different microwaves. Okay? I have my grandma's old microwave and the new microwave that you can buy right now. So explain what the number in the equation represents and how do the two equations compare to each other. So we have grandma's microwave, the 500-watt microwave, and the new microwave, a 1,000-watt microwave, and the equation is one is C equals 0.5 T plus 20, and C equals T plus 20. So look at the two equations and compare them to me. Tell me what's the difference. Tell me what's happening. Okay. So what's that? What's that in front of the T here? What is it? What is that value in front of the T? 1. Yeah, which is your rate of change. That's it. Okay. Now let's start with 20. Both of them have the number 20. What is that? Y-intercept, which represents what in this scenario? The initial value of what? You guys can't give me just words. You have to give me a whole sentence. Thank you. So 20 degrees is the initial temperature of the coffee. So right now the coffee is at 20 degrees before I put it in the microwave. Right? In both scenarios I have the same thing. Okay? Now, how about the rate of change? So what's the difference in the rate of change? And explain to me. So what's the rate of change of the 500-watt microwave? 0.5. And that will be 0.5 what? Because remember, rate of change has to have units. Degrees coffee in this microwave, right? The rate of change is 0.5 degrees Celsius per second. What does that mean? Explain that to me. So when you put the coffee in the microwave and you put it for 10 seconds, right? What's going to happen every second? Okay, so the temperature is going to increase by 0.5 degrees for every second you put it in, right? So for this one, the coffee temperature will increase by 0.5 degrees Celsius, right, per second. How about for the second microwave? 1 degree per second. So it's gonna for this one, the rate of change is 1 degree Celsius per second, right? Which means the temperature will increase 1 degree for every second you put it in. Which one's a better microwave? So if you wanna heat it to, let's say, 40 degrees, right? This one you're just gonna have to put it in the microwave for 20 seconds, right? Plus 20 seconds, it's gonna be 20 times 1, that's 20, plus 20, that's 40, right? How about this one? How many seconds do you have to put it in? 40 seconds, right? You have to double, because it's gonna take double the time. Okay, so, and then for the 20 degrees, the initial coffee temperature is 20 degrees Celsius. So, does this make sense to you? Like, this is an everyday life scenario, right? Like, this is what 1,000 watt mean. This is what 500 watt microwave mean, and that's why there is a difference in price, because, you know.
We can understand by the watt, right?
Huh?
We can understand the result
Yeah.
by the watt.
Yeah. Yeah.
1,500.
Okay. All right. Now, again, as I told you yesterday, is most of the time whenever you're going to collect data or you're going to see data, the data are going to come to you as points, right? So in this year you have this, in this year you have this, in this year you have this, or you can look at, let's say, number of female versus number of male in the classroom, or you can look at whatever, right? So when you're collecting data as a researcher, as a company, or as whatever you are, you're going to collect as points. Now your job is to put them on a graph so you can explain the trend that's happening. Okay? So we can use what we call linear model or linear regression. To model data that appear to be linearly predicted. So the regression line or the equations can then be used to analyze the data and make predictions. The closer the regression line, which we call the line of best fit, is to the data, the more reliable the prediction are likely to be. What does that mean? What does this whole statement mean? We're looking at, so let's say we have this, okay? I'm going to show you this. Let's say I have this. What can you tell me about these points? They're a pretty straight line, right? If I actually plot this on Excel, right, and I ask Excel, find me the line of best fit, right? It's going to find me a pretty good, close we do that on Excel? How can we get Excel to graph for me? And how can we get Excel to find the equation for me? And how can we use that equation to be able to predict what's going to happen in 20 years or 30 years or 10 years or whatever, how many years later? Okay? Because the whole reason we do this is to know what's going to happen next, right? Or what happened before we collected data, what might have happened long time ago. Okay? So here's an example. So the following table shows the median age. Median means median. What's the median though?
Between 20 and
It's the middle. The middle, right? Is the middle. Mean means the average. Okay, median means the middle. The following table shows the median age of Canada's population from 1975 to 2000. Okay? So in 1975, the age was 27.4, 1980 is 29.1, and so on and so forth. How can I graph this then? Number one thing, most of the time you don't want to graph like 1975, 1980 on your x-axis. Okay? So you're going to have to state that 1975 is your year 0. Okay? So most of the time that's what you want to do. Okay? It's usually say that in the question. Now this one does not say it, so I can, if you want, we can keep it the same and then use 1975, 1980, 1985, 1990. At the end, the equation is going to be different, but then when you do your prediction, it's going to be the same. Okay? So for now, unless the question says, let 1975 be your year 0, then you're going to have to change your numbers to 0, 5, 10, 15, 20. Okay? Why am I going 0, 5? There's 5 years between 1975 and 1980. Okay? But because in this question it doesn't say let 1970 be your year 0, I'm going to keep it the same. Okay? We're going to see some examples. All right. So we're going to use Excel here. Okay? So look what happens when I put these numbers on the graph, on Excel. So you guys have to read these numbers for me. One of you, maybe Olivia, would you be able to read that for me just so I can, because I can hear you? Yeah. Okay. So when I open Excel, I'm going to try to make it a little bit. So start with 1970. 1975 is the first year?
Yeah.
Okay.
1980.
Yeah.
1985.
No, put it down.
Put two together.
No, just because I don't know what's going on. 1985.
And 1990. 1995.
Yep.
And then 2000.
Okay. Yep.
Well, age?
Yes.
Okay, so 27.4.
27.4. Yep.
29.1.
Yep.
31.0. 32.9. 34.8.
Yep.
And then 36.8.
0.8.
Yeah.
Okay. So you always put your X on the in the first column and your Y in the second column. Now, to graph, this is what you have to do. You're going to have to highlight both columns. You're going to highlight the data. And then you have to press insert. So you see that insert button right here? When you press insert, you're going to have different options. Okay? We are looking for the graphs because that's what I want to do. I need to graph. Now, if you get closer, I can't make this any bigger. But if you guys get closer, you see that this last one right here is a scatter plot, so it looks like dots, okay? The one that you always have to pick is the first one. So you always have to pick the scatter plot with no lines attached to it, okay? So insert, you're gonna go to the graph. Excel the downloaded version, you can plus, and then next to the plus, you'll see the axis. So you want to make sure that you check that out. You check it. So when you check it, it will add the axis title on the top, on the X and Y. Okay? We will change them later. Okay? So right here, what did I have? The median age. Oops. So median age, and right here you're gonna say, what did we say? This one is year.
Yeah.
And then you always have to enter a good chart title, so when I'm reading, I know what I'm looking at, right? So you can say that median age of Canadians from 1970 to 2000. Okay? Make sure you spell it properly. And you should be using capitals. Okay? Are we okay with this? Now, you see how my graph is a little bit like too high up, right? I can change this scale a little bit so I can see it better. This is not a must. This is just to make your graph look a little bit cleaner, okay? But then if I am a person that I'm looking at your graph, I would like to see it like this, because then I know that I'm starting in the 20s. If I change my scale, so if I start, instead of starting at 0, I am starting at 20, let's say, right? Look what happens, right? Now I don't, because this here, it's kind of like, this is what they do in commercials, right? If they want to show you, oh, there's a slight increase in this because they changed their scale, okay? You don't have to change that one, but if you do want to change it for it to look better, because like all your points are kind of in one area, what you can do is you can double click on your y-axis, and then in here where you have minimum, maximum, you can change your minimum to 20 or whatever the minimum that you want it to be. Okay, so I went back to this here. Are we okay with this? Now, here's the important part. I want to add a trend line. How do you, when you're looking at these points, what do you think? They're pretty straight lines? They're pretty linear? Okay, good. So here's how I add a trend line. Press on one of the points, doesn't matter which one, press on one. Then you're gonna right click, and then you're gonna say add trend line. So the one before last is add trend line. So when you say that, you're gonna see that you have different options. You have exponential, linear, logarithmic, polynomial, power, moving average. In this case, because I know it's a linear function now, I'm assuming it's gonna be linear, I pick linear. Two other things that you have to pick there would be display equation on the graph and display R squared. We're gonna talk about the R squared later. But you have to click on both of these options at the bottom. So you see how you have now the equation, y equals something x minus something, and then you have the R squared. Do you think that's a good fit? Do you think that's a good fit? Yes. Now, the closer the R squared is to 1, the better it is. So this is 0.9939 or 4 nines, I can't remember. Okay, 3 nines and 5. That's a pretty good fit. That's almost like 99.95%. Okay, that's a pretty good fit. Are you guys okay with this? Okay. Now, the question is, how do you copy this into Word document? Because on the assignment, you're going to have to do these graphs, and then you're going to have to copy them for me to your Word document. So, on the computers in the school, we have something called the snipping tool. So you can look up this snipping. So you see, you can search for it. You can search for snipping. And the snipping tool lets you take kind of a screenshot of whatever you want to take a screenshot of. Okay? take a picture of my graph, I'll just highlight or I go around my graph and you see this is a picture of your graph. You can right click on it and then copy it and then you can dump it into a Word document. Because if you copy the graph right away from Excel and you go and change the numbers in Excel, it will change the graph on the Word document. So don't ever copy from Excel to the Word document right away because it will change it. Look at this. Paste and it's right there. Is that good? Okay, so let's see what we can do with this beautiful graph. So I'm going to use the snipping tool that's specialized in I have my own special snipping tool. So use the graphing technology to create a scatter plot of the data, draw a rough sketch of your scatter plot here, and describe any trend. So what can you tell me? What can you tell me about this? It's linear, right? It's almost perfectly linear. Okay. Determine the equation of the regression line or the trend line, which we already did that. What was the equation? Do you remember? Y equals y equals 0. Remember this. Write this down, guys. Write it down so you can give it to me. Write this down. So 0.3771 x minus 717.57. Okay, what is it? Y equals?
7.7.57.
So now the next question is asking you to predict the median age of Canada's population in 2020 using the equation first. So if you want to use the equation, how would you find the median age in 2020? What does 2020 represent in your equation? X, right? Because look here, year is on the x-axis, right? So 2020 is my x value. So if I do this, right, and plug in 2020, not 20, 2020. What do you get? 44.17. Does it make sense? Right, if I go back here, right, 44, yeah, right, because this is gonna keep going up, right? That's my trend, that's what's happening. Now, using the regression line, so Excel has a nice feature too. So can I get you guys to get closer to the board just so you see what I'm doing? For those of you who are far back and can't see the writing, because I can't make this any bigger. So if you double click on your x-axis, you are pressing this to expand it. Okay, very good. So you see, when I press the trend line, okay, when I'm on the trend line, if you see this one here, the forecast tells you what might happen later or also what might happen backward, okay? So you can pick either forward or backward. So if I pick, let's say, 2020, no, I should pick 20. Where is it? Where is it? There you go. So what I did is I picked 20 because I want to add 20 years to this, okay? So you see that when you add, again, so you press on the trend line, you're gonna say forecast, and then you're gonna forward it 20, because you were at 2000 the last, now I'm 2020. So if you look at this, right, you're gonna see that this point right here is about 44, right? So it will be an estimate, but it will be a good estimate for you guys, okay? It won't be exact like the equation, but it would be a good estimate, okay? So what happened here is that 2020, right? If I look at the Y value, it's about 44, okay? So this is using the graphic